These days, if you want to translate, you at least have to know about machine translation, even if you don't want to use it or even if you don't like it. You've got to know what it is because it is very much present in the market. The history of machine translation can be looked up in many places. I'm not going to focus on it here. The important point is that quality and use has been rising, and it's been rising unequally. Some important things would be back in Meteo, when, for example, in Canada, weather reports were done with machine translation very early on, because it's a closed semantic field. Hey, there's only a certain number of things that can happen in the weather, and it was just French and English, which are two very closely related language. So in those kinds of situations, machine translation has been working for a very long time. In Barcelona, for example, a daily newspaper is machine translated between Catalan and Spanish every day, the whole newspaper automatically. And then there's a minimal process of post-editing, that is, correction of the machine translation. What's important is that machine translation became statistical, leading to statistical machine translation, SMT. And from 2016, we have what's called neural machine translation, NMT, which really takes the statistical algorithms, the probability of linguistic elements aligning, and adds in elements of deep learning, of recursivity. We'll see some images of that in a minute, but I'm not going to give a course on machine translation. The important thing is it's been going up and down, and at the moment we are very definitely on an up. Although there are, as noted here, lots of remaining problems. You wouldn't know about the problems, though, when we have news like this from 2018. Google Translate processes 148 billion words every day. That is a lot of words, ladies and gentlemen. How many people on the planet? You work it out. You work it out. But the calculation that bothers me is, I think that there are 333,000 full-time translators and interpreters in the world, give or take 100,000. It's a ballpark figure, but that's what I reckon. Most part-time, but if you calculate the full-time equivalent. Let's be generous. Let's say they translate 3,000 words a day. Some companies require 2,000, so 3,000 is being generous. Do the calculation, and you find that at best, professional translators are churning out about 1 billion or just under 1 billion. So Google Translate is producing what? More than 99%. Professional translators, less than 1%. And that's when you start to get interested. You say, oh, machine translation is taking all this work away from professional translators. Well, not really. There's a lot of thinking that has to be done. People are using machine translation in many situations where they would not have used a professional translator or interpreter before. Okay, and they're processing lots of words that they don't actually read or need. For example, if I put a Russian language website into English so I can read it well, all those words count, even if I only need 3 words on that page. All right, but the billion has been inflated because not everything processed is actually used in terms of social need. Does it mean, though, that translation itself has definitively been automated? And that's the question. Are we entering a world where, like Austin Powers says through Google Translate, I live danger also like, okay, where we take the risks of trusting the machine But the CEO of Google does not seem too worried in announcing this spectacular feat. Which of those two attitudes should we take? Okay. Now, what we find out there is among professional translators of the older generation, I must admit, a reaction against machine translation. This is from the Quebecois Association of Translators, who are particularly reactionary in that sense against what's going on in the world, where they make the point that machine translation will not grasp all the nuance and the importance that's in the text. So it would just be good for a gist to get a rough idea. But if you want a real translation, you will come to a professional translator. I think that's an erroneous way of thinking about it. It seems to set up, and that text does set up, an all or nothing approach to machine translation. Either you come to a human who will do everything, or you go through the machine. But lots of people are quite good at correcting machine translation themselves, especially if they know the subject area. And then lots of professional translators can work better and faster by turning to post editing, that is, by correcting machine translation. So I think we're entering a world where it's not fruitful to think in an all or nothing way about MT. Let me give you an example quickly of the kind of progress that has been made with machine translation since 2016. I hope you don't know German, because then you will need some help, perhaps machines, to understand this text. It's from a conference that happened in Zurich, and it was on machine translation, as it happens, conveniently so. Now, if I put that German into machine translation of the kind we had in around 2000, okay, prior to statistical machine translation, we get some quite wonderful creations. It's very poetic. Let me see. It is, of course, in the future to talk, to that be translated simultaneously from your mobile phone. Whoa, that's a hard one to get around. Okay. And then, to what extent will facilitate the language cultural communication in the Switzerland or difficult? All right. And this is the sort of thing that got MT a really bad reputation, and people would make fun of it. Great fun in some cases. Okay. Now, if we move on to what we have these days, I think I put this through DeepL, you find that first sentence now comes out as, will it be natural in the future to have conversations that are simultaneously translated by the mobile phone? Now, I could post edit a bit. I don't like the mobile phone. I would prefer mobile phones, plural, which gets rid of that. And I think I would probably undo that German compound adjective language cultural, which is easy to do. But the post editing required over here is minimal. Here, it's so much, there is so much correction required that you would wipe away that suggestion and translate from scratch in a fully human way. Okay, and that's the difference from the transfer approach that we found in Systrad back in the day to what we have these days, which is not of absolutely publishable quality, but it's certainly reached beyond that tipping point where it makes sense for a professional translator to come in and post edit. Now, what's interesting, if you compare these, we can figure out why it went wrong. And here, I apologize if you don't know some German. The problem was that word there, selbstverständlich, which means self-understandable, okay? And it can be an adjective or an adverb. Now, in the good version over here, it got it correct as natural, an adjective. In the bad version, it got it wrong as an adverb, of course. And so it got the wrong grammatical category, and then the whole thing messed up from there. All right? So sometimes a minor ambiguity in the ST can have disastrous results when you use MT into the TL. How does neural machine translation predict that this word here is an adjective and not an adverb? I'm just showing you pictures from the inside the system, okay? What it does, it goes and compares that sentence with many, many other similar sentences and the way they are translated in the database. And then it does the same for each word in that sentence, okay? So you get probabilities for, if you like, this phrase, all right, selbstverständlich, and then the probability for what's on the left of it and what's on the right of it. And those probabilities become models of deep learning. And you get the most probable rendition of this item given that technically codex, given the things that are to the right and to the left of it. That's the deep learning, more pictures of deep learning, lots and lots of processes going through databases. That's all I'm going to say about that. Okay. Now, and it gets it right. Not always, but we'll see. We'll see some of the problems here. Now, this means that when we work with machine translation, we can do it in different ways. If we get this scale, which is interesting, from letting the computer do everything down the bottom there to, wait a minute, letting the human do everything down the bottom, and up the top we've got the computer doing everything. There are lots and lots of levels at which we can interact with automation, in this case, with machine translation. So we could, for example, let the MT propose an alternative, or let the MT narrow the selection down to a few alternatives, which is a very good way of using it, okay? And then we could require human approval of the MT propositions. So usually post-editing is working somewhere around this area of human-machine interaction. One alternative, okay? What's interesting in most of the MT systems out there is that they don't just give you one alternative. For example, this is Google Translate for that problematic term in German. If you look at what the machine gives you at the bottom, we have the information that it can be an adverb or an adjective, and we have possible ways of translating it, many possible ways. So even though it proposes one, and it would be wrong in this case, if you know what you're doing, you can use it as a very easy to access dictionary and correct it in accordance with the grammatical information that's available there. If you do that in deep L, that's the same German sentence, you've got selbstverständlich, self-evident they have here, not natural, but click on that and you get all these alternatives and you select the one that you think is best in the situation, as I said, for the function to be carried out. And over here, we've got other information about self-evident and contextual information. Okay? It knows it's an adjective, though, in all these situations. When you select one of these, the rest of the sentence is adjusted accordingly. Okay, so if you don't know about DeepL, it's great fun. Go and play around in the sandpit of DeepL. Now, here's a problem about knowing the unknown. It's as if neural machine translation was thinking, and sometimes not thinking in a very nice way. Let's take the word dancer in English, and I put it into French. This is DeepL, as you can see, and it makes the dancer feminine. How does that machine know that the dancer is feminine? If it doesn't, how does it know it's masculine? You don't, because dancer in English is unmarked for gender. But in French, you have to choose a gender. So how does the machine do it? Well, it goes through its database and it looks up all the dancers and it finds that most of the dancers are women. And so it puts danseuse, makes it a feminine. It's translating on the basis of probability within the database, okay? It gives you the possibility of making it a masculine dancer. That's fine. And if you don't know if it's a man or a woman, it gives you the possibility of a third word that is unmarked, interprète. But machine translation has been accused of being sexist because of this kind of upfront headline proposal. What's interesting, and this is where you can see how it's working, if I put in the adjective strong dancer, it's masculine. If I put in the adjective dainty dancer, it's feminine. So even though dancer is unmarked, these are marked in the database as being associated with men and associated with women, and that disambiguates the noun dancer. All right. So this is just to illustrate how the machine translation system is working here. It's not getting the probabilities just for dancer. It's then getting the probabilities for the words around it, and then putting those probabilities together to give a proposal. Can a strong dancer be a woman? Yes, you can come in and correct it. Can a dainty dancer be a man? Yes, you can correct that as well. Here's one of my favorite examples to illustrate how machine translation is working these days. Despacito. Myself, you know the song Despacito? Anyway, slowly, okay? Slowly, fair enough. Despacito is slowly. But if I put in the next line of the song, what is it? Despacito. No, and then it's what? Quiero respirar tu cuello despacito. It's just horrible. I want to breathe your neck slowly. No, it sounds cannibalistic. Not nice. Ooh. Anyway, what's interesting is that when we put that line next to Despacito, the translation changes. It used to be slowly, and it becomes nice and easy. Why does slowly become nice and easy? Well, in the database, they pick up this line and they find an English translation of the song. It must be, because it's singable. Yes, if you go Despacito, and here you go, nice and easy. Yeah, it scans in the sense that it has the right number of syllables. Okay, so this is how machine translation can bring up proposals that are absolutely functionalist. There is no linguistic operation that gets you from Despacito to nice and easy. But there is certainly a functionalist operation in terms of what's required in order to sing that particular song. I hope the song is still known by the time you get to see this. All right. I want to finish this presentation with some comments on some of the myths that are out there concerning machine translation. I get this all the time. I give this lecture or versions of this lecture, and somebody will always say, but I always translate better than any machine. Yeah, okay, yes, you do. I'm fine with that. There are several problems with it. The first, though, is if you look at it, the machine is not translating. No, it's no longer applying those linguistic algorithms, those transformations. That's not the way MT is working. It's working on the basis of mathematical probabilities. And it's locating a previous human translation because the database is full of human translations. If you like, it's rather like a dating service. You know, You put in the machine the thing you're trying to find. I'm trying to find a match for Despacito. I require this, this, and this. And it goes through the database and it brings up your proposed perfect match. Is it perfect? No, never. Like real life, okay? But that's what it's doing. It's going through previous human translations and finding the most appropriate one for your purposes right now, okay? NMT, neural machine translation, is finding and combining previous human translations. Also, it's not a question of whether you are better than the machine. It's the real question is, are you better with or without the machine? And in many cases, I propose, well, find out for yourselves. In many cases, you are better with the machine. Better, faster, and with better terminology in many technical fields. And the second myth I want to develop or attack or undo here is the notion of parity. Google and Microsoft both put out papers claiming different kinds of parity, that machine translation is now as good as human translation. Okay, so this is the one, Hassan, 2018, where they put out bilingual sentence pairs and had them evaluated by a lot of people, bilingual crowd workers, no idea who they are, and they asked which translation, the human one or the MT, conveyed the semantics of the source text. And the people were not able to tell systematically which ones were MT. Okay? Now, that's fine. It's a zero result because it doesn't say MT is better. It doesn't say there's any significant difference. It just says, hey, we did a lot of testing and we found no significant difference. Note, though, one, the test is about semantic content, not form. You know, there could be mistakes in the syntax, but the basic form can be recovered. But a lot of what we do with language concerns form. We need good form. We need it to be well written and immediately understood. The second, it concerns isolated sentences, like all the psychology tests. They've always isolated words or isolated sentences. No, language doesn't work like that. We work with utterances in the situation, trying to get things done. So the test itself is very, very much in that linguistic paradigm. And there is no risk. This is a complex argument, but bear with me just for a minute. If I have a page, oh, there's a page. This page of translation was done by a machine, and this page over here was done by a human. No, we'll do the other side, okay? This page, no, you can't see what it is. This page is done by a human. All right, now, let's say there are 3 mistakes here and 3 mistakes here. There are mistakes all the time. If the one done by the machine, it is very possible that the mistakes will be in a high stakes part of the text, where the function depends on that being correct. In the case of the human, though, because the human knows what's important and what's not important in a particular situation or to achieve a particular purpose, in the case of the human translation, the mistakes will likely not be in those high stakes parts. They will be in the low stakes part. Why is that? Machines can't look at the situation, they can't analyze risks, and they apply the same effort to the whole text. Whereas a human, just because they're aware of what has to be done with language, can work hard on the bits of the text that are most important, distribute risk accordingly. Okay, that is one very important reason why machine translation, as good as it is, has not yet reached parity with humans. That is why people need us. Not to replace the machine, not to fight against it, but I think to work with it in various ways.